A few days ago, I tried to build a rocket motor myself because I didn't want to buy one. But that project didn't go very well, so I took some time to research building techniques and tried again. But the outcome of this project will blow your mind. Building something from scratch that can fly is not an easy task. It requires a lot of skill, time, and hard work. On my first attempt, I thought it would be easy to build a rocket motor. I simply packed some clay and some not-so-pure black powder inside a cardboard tube and lit it on fire. However, the rocket motor just bounced off the base because the end cap exploded, and it landed near my phone, barely missing it. And if you haven't watched that video yet, please watch it first to understand the story. The link is in the description. After researching online and reading your suggestions in the comments, I made some changes to my building technique. I used a more efficient propellant, a perfectly sealed and hardened end cap and nozzle, along with a few other small improvements that you'll see later in this video. The propellant I used in the previous build was ineffective because I didn't pay attention to the ingredient measurements. Its burn rate was very slow, and after combustion, it left unburnt potassium nitrate behind. This unburnt potassium nitrate can easily choke a rocket motor by forming a thick layer in the motor's throat, potentially leading to an explosion. But this time, instead of using the old fuel, I made a new batch of rocket fuel. The old fuel contained potassium nitrate, charcoal, and sulfur. In the new rocket fuel, I replaced potassium nitrate with potassium chlorate. This time, I was careful with mixing and measuring the ingredients. The burn rate of this fuel is much faster than the old one. I was so happy after preparing it, but I didn't realize that the faster burning fuel would create a new problem. After preparing a better rocket fuel, I moved on to another problem. As we all remember, the end cap wasn't strong enough to withstand the intense pressure building inside the motor's hot core. To fix this, I came up with a simple solution. Instead of regular clay, I used adhesive clay to make the end cap and nozzle. Adhesive clay hardens after setting, making it perfect for constructing a durable end cap for a rocket motor. I bought this adhesive clay from a hardware store near my house. It cost me only 20 rupees for both. 2 problems have been solved, but a few more still need fixing. One of them is the old wooden ramrod. It doesn't fit perfectly inside the cardboard tube. This makes it difficult to pack the clay and propellant into the rocket body. To solve this, I found a stick outside and shaved it down until it had the exact dimensions needed for the motor. It took a little longer than I expected, but the new ramrod fits perfectly inside the tube, making it much easier and faster to pack the materials. The rest of the process was similar to my previous build. First, I packed some clay inside the motor. Before doing that, I rubbed the inside of the cardboard tube with sandpaper to create a rough surface so the clay could grip it. The clay was too sticky and kept sticking to the ramrod, so I used some powder to prevent it from sticking. After that, I made a hole through the clay for the nozzle, ensuring that the nozzle diameter was perfect. To prepare fuel for the motor, I added a few drops of water and hand sanitizer to our newly made black powder. I added water to create a dough-like propellant, making it easier to pack inside the motor. The hand sanitizer contains alcohol, which helps the wet propellant dry faster. This saved me a lot of time since the propellant didn't take long to dry inside the motor body. After preparing the fuel, I slowly and carefully packed it inside. And just a quick reminder, playing with this stuff is very risky. If you don't handle it carefully, you could end up in a very bad situation. So always remember, safety first. If a rocket motor doesn't have a long core, it won't fly, no matter how powerful your propellant is. A core provides a much larger surface area for burning, rather than just burning the bottom of the propellant. To create a core, I used the metal skewers from my previous build. With them, I carefully made a straight hole inside the propellant. The results were very good. As you can see, the core is completely straight and clean. I did a great job making it. Now, the motor needs some rest after that intense penetration, so I let it dry in the sunlight. Using a black powder fuse for ignition is a bit old-fashioned, and homemade fuses aren't very reliable. So I decided to make an electric igniter instead. An electric igniter, or E-match, can ignite a rocket motor or other pyrotechnic devices using electricity. E-matches are one of the most reliable ways to achieve ignition. To make one myself, I used small light bulbs. First, I sanded the top of the bulb with sandpaper to create a small hole in the glass. Then, I carefully filled the bulb with a small amount of black powder. This step required great caution because if I accidentally broke the filament inside the bulb during the filling process, it wouldn't work. Working with such small components is tricky. You have to be very gentle or you could ruin everything. I recorded one in action to demonstrate how it works. This E-match creates a small explosion inside the motor to ignite it. After the propellant had completely dried, I placed a piece of paper on top of the propellant grain before sealing everything with clay and letting the motor dry for a few more hours. To test our motor, we placed it between some bricks, since we don't have a test stand yet. For safety, we used a very long wire so that, in the event of an explosion, my friends and I would stay out of range. I didn't expect that. I thought my rocket motor would work just fine, but it exploded. I followed the building process perfectly, but I still need more experience. I wasn't happy at that moment, but my friends were. This video ended in failure, but I will learn from it and try again until I build the perfect rocket motor. I'll see you in the next video. Until then, bye-bye.